Hi, everybody. I'm doing this recording in my office because I tried to do this during the lecture, and somehow the combination of projecting while doing this on Zoom and trying to record it just didn't work. So here with a day's delay is the missing lectures, the missing portion of chapter 19. The first one is going to be part 3. And so I'm going to go to share my screen and put up what we need to look at. And here it goes. So first of all, let me turn this on. We are working on population ecology. And so this is going to be part 3, which deals with life history. Now, as far as life history traits are concerned, those are the kind of things that are very important for organisms from an evolutionary perspective. Because remember, when it comes to the evolutionary aspects of all this, you're primarily concerned with survival and reproduction. And how that plays out, how easy it is to survive and how easy it is to reproduce, that is part of life history. So when you're looking at the kind of factors that influence this, they're clearly abiotic factors, which are the ones that the organisms cannot influence. And then there are the biotic factors, which clearly are due to the organism itself and other organisms around it. And so what we're trying to figure out here is what is the timing, the optimal timing, or perhaps the strategy for timing of reproduction. And then, of course, once reproduction is accomplished, then the organism could die. And so just taking a look at the key traits that this might include, we have, first of all, how old is the organism when it first can reproduce? And perhaps, is it a good idea to reproduce that early? Secondly, how often does the organism reproduce? Is it maybe once in a lifetime? Is it multiple times in a lifetime? And then, of course, how many offspring is it going to produce each time it reproduces? And then lastly, is there any opportunity for any parental care? Now, when you look at the organism on the screen here, this is a century plant. It's a kind of agave, you might say. And if you drive around the high desert, then you can find a lot of these. There's quite a few of them that are producing this big tree-like offshoot, and that's actually the flower. It's the stalk that has the flowers on it at the top, and then of course that produces seeds, and this is what the plant does right at the end of its life. Many of these plants can be quite old, hence the name century plants, even though they don't tend to be a century old. But if you look at these key traits again, age at first reproduction is therefore late in life. So when it comes to age at reproduction, it's not a matter of 1 year, 2 year, 3 years. It's a matter of when during the lifetime is this going to happen. So in this case, it would clearly be late in life. Frequency of reproduction 1, number of offspring is going to be many, and level of parental care is 0. So you can see that not all organisms do, early, small, small numbers, etc. There's a distinct mix of all these key traits. So let's take a look at 2 extreme life history strategies. One of these strategies is called the opportunistic life history strategy, and the other one, the equilibrial life history strategy. Now, when I'm talking about these, I want you to understand that these are extremes. They're sort of on opposite ends of a spectrum, and there are others that could be in between. So just to introduce what is opportunistic first. Opportunistic life history is an individual that matures very quickly and reproduces young. So in terms of survival and reproduction, these are organisms that are not necessarily surviving very well. Maybe it's the type of organism it is, maybe it's just because of threats from predation, whatever it is, they have to mature quickly in order to reproduce. If they don't mature quickly, then they might never get the chance to reproduce. So it is a different strategy from some others. Secondly, there is, of course, an advantage. If you mature very fast, you hatch out of your egg, or you metamorphose, if that is a larval stage that you were in, then as soon as you're mature, then you can take care of any favorable conditions that come along and reproduce. And then maybe you can reproduce more than once. So maturing quickly has a distinct advantage. If that's what you can do, then so much the better. Producing many offspring in this sense is also a good strategy. If your survival is not certain, and if you face threats throughout your life, then as many as you can produce at any given time, that's going to secure that you contribute to the next generation. So production of many offspring, well, it's a little bit like throwing mud against the wall. Some of it will stick, right? And so this is the key here. You want to make sure that some of your genetic material gets to the next generation because that fulfills your biological destiny. Now, these types of organisms generally exhibit that type 3 survivorship curve. That's the one where you have a very steep decline of the survivorship at the very beginning of life, and then it catches the corner so that once organisms reach a certain age, then survival is a little bit easier for them. But that's still, it's a very steep drop. Now, as we'll see in the next section, these types of populations also tend to increase in numbers very quickly during certain times of the year. And so they follow the so-called exponential growth model, and more about that in the next section. Now, the opposite extreme of this is the equilibrial life history strategy. And there you have organisms that mature and reproduce later in life because they can. They don't have to rush into reproduction because based on the overall type of organism they tend to have more substance perhaps, or they're less easily eaten by something else. And so they have a good opportunity to mature and wait with reproduction until they themselves are situated better in their environment. Now, as a consequence of this, these may also develop a social context to their lives. And this could be any elaborate courtship displays. This could be, taking care of family. This is the kind of thing that humans do. So any kind of elaborate social context is something that depends on more time, having more time to deal with maturation and reproduction. Now, of course, some of this doesn't apply to certain types of organisms. There are organisms that cannot have any social context because, well, they're not behaving. So plants are like that. So it's not always the case that reproducing later in life, like that century plant, means that there's going to be any social context. In addition, these types of organisms tend to have fewer offspring than the opportunists, and that's a little bit of a trade-off. One thing you can say is that if you have many early on, then you can accept that many will die and some will be left over. That's a statistics kind of a thing. But if you decide to have fewer offspring, then you really need to be sure that those are actually going to survive. So if you want to be successful in moving your genetic material to the next generation, then it means that you need to produce offspring that are going to stick around one way or another. And of course, to ensure that would be to have some parental care. So this group of organisms, the one that have this equilibrial life history strategy, they're more of a caretaking type of organism, and that includes part of their social context. Now, these organisms are the ones like us. They are on a type 1 survivorship curve where early in life, survival is basically assured, and then only near the end of the potential lifespan does survivorship actually drop. And as a consequence, these types of organisms have a different growth strategy, and the populations may actually go up to a certain level and then stabilize. And that's called the carrying capacity, and more about that later as well. And so just to finish up here, I want to contrast these two. And so here you can see in the one column, you have the wildflowers as an example, and then in the other, you have large mammals. And these two categories, these two columns are the opposites, these extreme opposites. But there's some kind of things that are, a little bit here, a little bit there. So for example, let's run through this and consider a frog. I mean, frogs, let's say a frog in North America, there are 4 seasons, it's a temperate climate and so on. So the climate is actually relatively predictable. So that would be something from this column here. The maturation time in these frogs is relatively short. The lifespan is relatively short. The death rate can be high. The number of offspring, that depends. Some frogs, especially toads, they produce many offspring, and others only lay a few eggs. Number of reproductive periods, several. And then timing of first reproduction is relatively early in life. So you can see it's from here to there to back to here to back to there. So there's a mix when you're looking at these frogs. And so just based on having one particular type of organism, you can't immediately say it goes here, it goes there. It certainly may not be right at the extremes, but there could be a little bit of mixing going on. And so it's important to just remember what these characteristics are and always have sort of a mental checklist of what can happen there. And that is part 3. So I'm going to pause this, and now we can go on to part 4.